Pumps are a fundamental part of both KYPipe and surge models. In surge, pumps shutting down and starting up are a primary cause of transient surge pressures in a piping system. When a pump node is added, the default pump type is initially a table type pump. The pump type is shown here. This is a good all-around pump type for KYPipe and surge analysis. With a table type pump in surge, a pump shutdown or pump startup can be modeled. If you want to model a pump trip where the pump loses power and runs down under its own inertia, then a file type pump or a file table type pump is required. Setting up a pump shutdown, a pump startup, and a pump trip will be discussed in a later video, and we will also discuss file type pumps for surge in another video. There is a help screen for answers to common questions about pump input data here. In the Node Info window are the various inputs for an individual pump. Here is a multiple pump selector which allows the input for one pump node in the model to represent 2, 3, or more parallel or series pumps. Let's draw a single pump. This single pump can be used to represent our pump station. We will select 4 parallel pumps. Now this single pump node represents 4 pumps in parallel. If you use this option, all pumps will be operating in tandem. Because the friction and minor losses for all the piping within the piping system are not present in this configuration, a pump resistance value is input which accounts for these losses. Use the resistance calculator tool to find an equivalent value for the piping resistance for all of the piping within the pump station that's not being represented by a single pump. For instance, the diameter of the piping, the length of the piping, and any additional minor losses. Let's say there's 2 elbows and you could have valves here. This is an equivalent resistance for the piping for one pump. The other pump data, which we'll discuss next in more detail, also represents one of the pumps in the group. It does not represent the combined pump operation. If you have multiple pumps in parallel or series, but they do not always operate together, then they should be modeled separately as shown here, so they can be turned on and off independently. Next, and most importantly, is the pump ID. Click the ID number here to open the head flow table. You can enter data in head or pressure. Simply select the units in which you want to input the values. In KYPipe, you may have an additional column of inputs here for efficiency. Efficiency is only used for KYPipe power cost calculations during an EPS analysis. Pump IDs work like a library. We'll input some head versus flow data. Our units of flow in this particular system is barrels per hour. Now, this pump curve is assigned to ID number 1, and we can then apply this same ID to the other pumps, as many pumps as we like. If you click on the other pumps, you'll see the curve data is present for all of them. If you want to input additional pump curves, you should select a new ID number Now we have a blank table, and we can proceed to input the curve data for a new curve. Now this curve is ID number 2. We could apply this curve to other pumps if we wanted to by changing the ID number. Now the second curve that I input is applied to this particular pump here. The recommended pump curve description uses 3 data points: a cutoff head at 0 flow, an operating point, and a third head flow data point to complete the curve. More data points are acceptable. As you can see, there are several rows available in the table. But care should be taken to avoid wavy or unusual curve shapes. I have some curves I input previously. As you can see, the shape of this curve is not a smooth curve as is created with a 3-point curve. I have another curve. This particular curve lacks a cutoff head, and so there's missing data between flows of 0 and about 180. These shapes have the potential to cause convergence issues in the analysis, and so should be generally avoided. Most pumps have an associated check valve, and this is designated here. For KYPipe, the other check valve settings and the bypass line option can be ignored. In Surge, there is an option to make the check valve non-reopening. The check valve time is the time in seconds that it takes the check valve to close from the moment flow slows to 0. Check valve resistance accounts for the friction losses through the open check valve. This also can be estimated from the resistance calculator tool. These 2 values must be input, or defaults will be used instead. CV time could be left as 0, but this represents ideal check valve behavior and perhaps may not be conservative enough for your model. Check valve settings in Surge are discussed in depth in Dr. Lingaretti's webinar video, Modeling Check Valves. Check for other videos in this series as well. If a bypass line is checked, it will be assumed a bypass line exists around the pump but isn't visible in the layout. This bypass line will have a check valve to prevent reverse flow, and flow will pass through the bypass line if the inlet head exceeds the outlet head during a surge analysis. Enter the resistance for the bypass line here. A default speed ratio of 1 means the pump is operating at 100% of its normal operating speed. A speed ratio equals 0, along with the pump being turned off using this setting, means that the pump is operating at 0 speed or is closed. Other speed ratio values can be applied. This initial ratio must match the first change in the change table. See videos regarding pump startup and shutdown. This is used to change the pump direction. The arrow in the pump icon should point in the direction of flow. Grade is only input if the pump has no inlet side connection. Notice when I select this input, I get a message that both sides are connected. There is a pipe on the inlet side of the pump and a pipe on the outlet side of the pump. This pump has nothing connected to the inlet side, and so the model needs a reference for the available head for this pump. And we input a grade to account for this. Our elevation is 326. Grade refers to the hydraulic grade line, which is elevation plus head. So if this pump has an elevation of 326 and it has 10 feet of head available to it on the inlet side, we will input a grade of 336. This sets the available head to the pump, which is an important parameter and will influence pump performance. Lastly, there is a checkbox for ignoring changes. If this box is checked, any associated changes will be ignored.